Okay, so let's start here today. What is the square root of 25?
Plus or minus 5.
No, not plus or minus. Why is it just 5?
Because
It was given to us, right? It's given to us as square root of 25, so we just say 5. What about square root of 36? 6. Okay, so here's where we need to go today. You can't, okay, you can't do it until today. Okay? You guys are so weird. Here's our important information today. The square root of negative 1 equals I. Not a J. Not a J. It's an I. Okay? Square root of negative 1 equals I. I stands for imaginary. Not fake or pretend, but there's a whole entire study in mathematics of complex numbers. Okay? A complex number contains a real part and an imaginary part. All right? So here's the math behind what's going on here. Okay? We're not going to have to do this every time. I just want to make sure you understand the math. Okay? This is the same thing as negative 1 times 25, correct? Well, knowing properties of square roots, we can also do that. Correct? Well, what is the square root of negative 1? It's I, right? What is the square root of 25? 5. How am I going to write my answer? 5I. Okay? Now, something I need to be very clear about from the very beginning is that I is not a variable. Okay? I know it's a letter. I know we always use letters to represent numbers, which would mean it's a variable. This I is not representing a number. It's telling you this is the imaginary part. But the cool part about it is that it follows a lot of the same rules as we do with variables. Okay? And I'll show you what those are as we go through. But this is not a variable. It's an I representing the imaginary part of a complex number. Okay? So what if I said, what's the square root of negative 36? What could I say the answer was? 6I. Okay? As long as you realize this is the math that's going on, I don't mind if you go straight here to 6I. You okay with that? Okay. So we have to be able to do other things like this. For example, the square root of negative 50. Do you know the square root of negative 50? No. So we need to be able to simplify the radical here. Okay? So we do need to spread this one out a little bit. I know it's negative 1. And I'm going to choose 25 and 2. Guys, why would I choose 25 and 2 instead of like 5 and 10? Yeah, we know the square root of 25, don't we? So when we're breaking these down, let's choose numbers that we know the square root of. Okay? So what's the square root of negative 1? I. What's the square root of 5? I mean, how about if I tell you the answer when I ask the question? What's the square root of 25? 5. And what's the square root of 2? I don't know either. Okay? Now, how come I didn't write I 5 root 2? Remember how a minute ago I said they follow the same rules as some of our rules for variables? Do we write x5 or x2? No, we write our number first and then our variable. Same thing here. We want to write our number first and then our imaginary. Okay, so we don't want that. We want that one. Now, I mean, technically, this is not wrong. Okay? This is just more mathematically correct. And if we're trying to write mathematically correct, and then that's what we want. Okay? What about the square root of negative 72? How do we want to break it down? 8 and 9. Are you sure?
Yes, because 9 is a perfect square.
Okay, so if we know that...
And 8 is a
Oh.
You can take 4 and 2.
So do we want 8? Let's instead do negative 1 times 8 times 2... 4, excuse me. 4 times 2 times 9. Isn't that what you said?
Yes.
Okay. What's the square root of negative 1? I. What's the square root of 4? What's the square root of 2? I don't know either. What's the square root of 9? 3. Is that how I want to write my answer? How do you want to write your answer? Oh, excellent. Got it? Okay. One more. How about negative 3 times the square root of negative 100? What do you think a wrong thing people do is right here? They try to cancel it down negatives. Can you do that? No, that negative's inside. You can't mess with that unless you're taking it out somehow, right? Okay, so what do you want to do? Do you know the square root of negative 100? Yeah? 10i, right? Well, what do I do with the negative 3? We multiply it. So what's the answer? Negative 30i. Very good. Okay, ready? From here, it just gets easier. Okay? Yeah. So a plus bi is the form of a complex number. Okay? This is the real part. This is the complex part. Excuse me. The imaginary part. It makes a complex number. So why can't I just say a plus bi is abi or something like that? Can you combine real and imaginary? Guys, it didn't work in Space Jam. It didn't work in Who Framed Roger Rabbit. And it didn't work in Enchanted. No. They couldn't exist together. They had to be separate. No. I loved the movie. No, the movie was good. Loved it. Okay? But you can't combine real and imaginary. Okay? So keep that in mind for me. Okay? You need to be able to do some basic operations with complex numbers. For example, 2 plus 3i plus 3 plus 4i. Now, sometimes the parentheses confuse people because they're like, ooh, parentheses are supposed to multiply. Well, all it's doing is telling you this is one complex number and this is one complex number. What am I allowed to combine? So like terms is the way that you know how to talk about it, right? It's kind of like terms, but it's really real parts and imaginary parts. So I'm really glad that you chose that vocabulary to use because that's the vocabulary you know, right? And as long as you realize we're talking about real parts and imaginary parts, I don't mind if you say combine like terms. Is that fair? Okay. So I do want to combine the 2 and the 3 to make 5. And I do want to combine the 3i and 4i to make 7i. Done.
So you're just like grouping it?
Yeah. Grouping real and grouping imaginary. That's exactly right. Now, if you're not careful, this one can be tricky. But that's only if you're not careful. Can you tell me why this one can be tricky? Because you're subtracting, right? So here's the real part, 3 and 2. So I'm saying 3 minus 2. 1, excellent. But then I have my imaginary part, 7i and negative 3i. And so a lot of times people will say 4i. Well, it's 7i minus a negative 3i, right? Which would be 10i. Absolutely, you could distribute the negative, okay? Making sure each term has the negative. So, yeah, that would actually be a really good idea, okay? Not everybody needs to do that, which is why I didn't show you. But if you need to do that, absolutely. And just for the record, that's what I do most of the time. I distribute my negative, okay? Just as a side note, this was my name in high school growing up. Just for the record, yeah. Okay, yeah, okay. It's fine. I'd say I'm over it now, but I still don't like to wear my glasses in public. I just have my readers on right now. Okay. Any questions? Okay, so what's left to do? No, not yet. Multiply. Okay, so if I'm multiplying, it'll look like 2 plus 3i times 4 minus 5i. And so at this point, somebody will say, wait, are we allowed to multiply real and imaginary?
Yes.
Think about the rules of variables. Are we allowed to multiply 2 times 3x? Yes. So that's one of the rules that this follows. Okay, so can we multiply real and imaginary? Multiply, yes. Add and subtract? No. Okay, so we distribute. 2 times 4. 8. 2 times negative 5i. Negative 10i. 3i times 4. Try one more time. 12i. 3i times negative 5i. So negative 15i squared. So this comes to our second main thing of the day. Okay? Our first main thing, that's not the right page. Where's the right page? What did I do with it? There it is. It's just at the bottom of the stack. Our first main thing of the day was that I equals the square root of negative 1. Well, can't I find I squared? Couldn't I just square both sides? Yeah, it sure is. It's negative 1. I squared equals negative 1. Okay? So going back to this problem right here, this equals negative 1. So what is negative 15 times negative 1? 15. So I have 8 plus 15. 23 plus 2i. That's right. Now, I need to show you guys a side note real quick. Okay? It's a little commercial break. Just need to show it to you real quick. Okay? We said at the beginning that I equals the square root of negative 1. Correct? And then we said I squared equals what? Negative 1, because I squared both sides of this, right? Guys, how would I find I to the third? Can I just multiply these two things together? I times I squared, wouldn't that be I to the third? Well, isn't that negative I? Isn't it? What about I to the fourth? How would I find I to the fourth? Multiply what again? So couldn't I square this one? Squaring I squared would get me I to the fourth? Well, what's that squared? Which is? 1. And then what about I to the fifth? How would I find I to the fifth? I can multiply these two or I can multiply these two, right? Because when I'm multiplying like bases, I add the exponents. That's another rule that this follows.
So
Negative I.
No, it's just I.
It's just I. Because if we multiplied these two, negative times negative is positive, right? So it's just I. What about I to the sixth? I could square this one. Right? I could square I to the third to get me I to the sixth. So I would get I squared, which equals negative 1. What about I to the seventh? Negative I. What about I to the eighth? Zach? How do you know that? Oh, it's a pattern. So what would I to the ninth be? I. What's I to the 10th? Negative 1. So here's the reason I'm asking you this. Here's the reason I'm going through this little thing with you right here. Okay? Yesterday afternoon, I was sitting with a young man working on some ACT practice problems. And it said, what's I to the 11th? And he was trying to take this and multiply it times itself 11 times. Yeah, exactly. That's almost exactly what I said. I was just like, let's not do that. Let's know the pattern. So all we really have to know are these two, right? Because you can find the rest of it and then realize the pattern starts again over at I to the fifth. So we wrote this and went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What's I to the 11th? Negative I. Okay? That's on an ACT or SAT test that he was getting ready for. That's coming for you guys. Okay? I know that you're not taking an ACT or SAT tomorrow because we don't take tests like that tomorrow. Okay? But It's coming soon, and I want you to remember this. Okay? So, a couple more things from your notes, for your regular notes. Okay? So back to the show. Back to the show. Back to the regularly scheduled program. Can I see if I can trick you? Yeah? Okay. X squared plus 25 equals 0. How do you solve this? Hey, do me a favor real quick. I'm going to start writing down the steps, and I don't want you to say anything until I get to the very end, because I want everybody to have a chance to try to figure this out. Okay? I'll tell you when I want you to talk. Just a minute. Let everybody have a chance to think about this real quick. Okay? So just let me write down the steps. Everybody okay with these steps so far? And then there's this step. Don't say anything yet. Can somebody tell me what x equals? Plus or minus 5i. Why is it plus or minus? We had to add the root sign into the problem. Remember that? Okay? If we add the root sign in, we add the plus or minus on the answer.
Good job, Zach.
Okay? Any questions about this? You got it okay? All right, so the other thing I want you to really keep in mind is that what if I had an equation set up like 2 plus 3i equals x plus yi, and I said solve for x and solve for y. That looks like a mess, right? Except you just have to know that the real parts have to be the same. What's x equal? 2. The imaginary parts have to be the same. What does y have to equal? 3. Done. Don't let those kind of problems be too difficult on you. If it's giving you a complex number equaling a complex number, just remember that the real parts have to be the same and the imaginary parts have to be the same. Okay? Any questions? All right.